Now next, just pipping Jungwan at a distance of 6,000 miles, one of the few Tremi finalists I've met before, because I hosted their final, and it's the first ever winner of Famelab Mauritius, Roshnee Rajkomar. After a chemistry degree from the University of Mauritius, Roshnee has somehow survived 10 years in one of the toughest jobs in the world, being a secondary school science teacher. It may or may not be coincidental, she's also done courses in self-defense and wrestling. Roshnee is now a chemistry educator at the Adventist College in Mauritius and studying for a postgraduate certificate in education. She says she's passionate not only about science, but about transmitting that passion to the students. It clearly works, so for the next 3 minutes, consider yourselves all temporarily enrolled in the classroom of Roshnee Rajkomar.
Imagine one of your loved and dear ones is lying on a hospital bed, fighting for his life. He has a life-threatening infection from which he is not recovering because none of the antibiotics has been given is working. That could be the story of any one of us here, because like most of you might already know, those entities that are very often responsible for our diseases, bacteria, have evolved and become more resistant even towards new generation antibiotics. So what could possibly save you or your loved ones from these multi-resistant bacteria? You are currently looking at one of the possible solutions. Not me. Light. Let me tell you how. Light is a form of energy that can be characterized by different wavelengths. Now we have these substances called photosensitizers, which if you happen to shine a light on them, they will absorb the energy and become activated. And they, in turn, will react with oxygen molecules, just like the one that you breathe, and cause these oxygen molecules to move to what we call an excited state. And this excited form of oxygen is so reactive that if it happens to be in the presence of a bacterial cell, it will simply kill it. Now, how do we go about it? Let us say you have an infection somewhere on your skin, or even inside your body. You take a little bit of the photosensitizer, you apply it, or you can even inject it or swallow it. Then you wait for a few minutes, because that is the amount of time that the bacteria are going to take to absorb the photosensitizer. And after a few minutes, you shine a light of a particular wavelength on it. Or if it is inside your body, you can direct it in there using optical fibers, that are materials that can carry light for a distance. And after a few minutes, your bacteria are dead. Now, some of you might be wondering, if this excited form of oxygen is so reactive, what would possibly stop it from killing the cells of your own bodies? Now, this is the interesting part. The structure of the bacterial cells are such that they will absorb the photosensitizer much more quickly than the cells of your own bodies. So when you have applied the photosensitizer and waited for a few minutes, the concentration of the sensitizer is highest in the bacterial cells, so the cells of your own bodies are spared. This extraordinary combination of light, a photosensitizer, and oxygen to cure diseases is what we call photodynamic therapy. Basically, minimal side effects, and most importantly, no bacterial resistance. Thank you.
So this is obviously one of the great stories of our time. What are we going to do after operations in the next few years as our current antimicrobials stop working? So what you've described sounds nice and simple. It's brilliant. You get a thing, you put it on, you shine some light, problem's gone away. Why isn't it happening right now in hospitals?
It is. Actually, photodynamic therapy, rather photochemotherapy, is already being used to treat cancer. So the research into photodynamic therapy to treat bacteria, that has lagged behind because of antibiotics. So actually, the existence of this method has been around for about 100 years now. And it was only about in the 1970s that it started to develop for the treatment of cancer. But it's only during the past 10, 15 years that the interest has increased because of antibiotic resistance. So that is why it is now being looked into. Actually, it's already being used to treat some form of acne, which is caused by bacteria, and even gingivitis for dental use. So it is already being used. But it's only now that we're looking into the different possibilities of treating different kinds of bacteria, gram-positive and gram-negative bacteria. So yes, it is already there.
And what are the downsides?
Okay, one of them would be when you have treated the person, he would be sensitive to light. So you would have to wait like for about 48 hours before you could go out into the sun.
Do you have to become a vampire?
Just for 48 hours, because after that, our system, it will remove the photosensitizer through the kidneys and all, and you'll be fine after that. And some of the patients who have already been treated for chemotherapy, one of the things they experience is a slight tinging effect, and that's about it.
Okay, one last question. I think Quentin's not stood up yet. So we have our own microbiome. We are covered in bacteria. We have more cells that aren't human and don't have all the human DNA. So what about those? What's this therapy going to do? You know, isn't it not going to kill me?
Yes, actually, one of the fields of research about that is to get it to target certain types of bacteria. So if, like for example, not all bacterial cells are similar in terms of the structure. So most of the research which is going on is to try to target the right bacteria using the right photosensitizer, using the right kind of wavelength for that to activate that kind of photosensitizer.
Brilliant illumination and inspiration from winner of the Mauritian competition, Roshnee Rajkumar.